Hello, everyone. So we are going to move on to the second part of the statistics lecture. Almost finished already. Okay, after this, there's just one more lecture. Oops, just one more lecture on statistics, and that's the end of SHP. So this one is number 17, and this statistics is called confidence interval. Okay, so confidence interval usually used to calculate if your sample size is big lah, more than 30, 30 or more. Okay, so for to calculate confidence interval, you need to have level, okay, in order to calculate interval and vice versa. So these two are always together. So what is actually confidence interval? So the statement A here, right? They say that you guys spend, sorry, you're older than teenager, right? You all spend 5,000 hours of television program and blah blah. Okay, this is the average. But if you write, would spend 4,000 to 5,000 hours, this is considered a range really. So this is like a interval really. Okay, so this one is 1 point. That means you average 5,000 done exactly 5,000. Right? For this case, it can be between 4 to 5,000. So the estimate is around 4 to 5,000 hours. So this is considered an interval really, like a range. So this is what they're trying to say. So you can see here that if I write 27.3 plus minus 0.4, this is an interval. Plus minus 0.4 is an interval. Okay, so from just now the range it will be 26.9 to 27.7. This mu here is the mean. The mean is the center, which is 27.3 here. Okay, and because it's plus minus 0.4, right? So the lowest value will be 27.3 minus 0.4, which is 26.9. And then 27.3 plus 0.4, which is the largest value, 27.7. So this whole range here, or this plus minus 0.4, is your interval. Okay, and as mentioned just now, usually your sample size must be bigger lah, 30 or more. Okay, so that's your interval. Then after that, how confident are you that your data falls within this range? So you need a percentage. How confident you are. So this is called the confidence level. Level is always in percent. So that's why I say level and interval are always together. Okay, so confidence level is how many percent confident are you that your data falls within this range. Okay, so are you confident 97, 95% to fall within this range? So if you want to be more confident, of course you have to make your range bigger lah, right? So you feel safer, right? Because or this larger range, okay lah, most likely my data fall within this range because it's bigger range. Okay, so if it's a very narrow one, your confidence level might might be lower lah, because it's quite difficult, right, to meet that range because it's very narrow. Because if your range is bigger, then you have more confidence that it will fall within that bigger range. Okay. But anyway, in statistics, right, for confidence interval, these are some of the common uh, confidence level, but the percentage that people use 90, 95, 99. Okay. This is what I'm saying. Just now. Confidence level tells you how sure you can be that your data falls within that interval, that range that you give. Okay. So it's expressed as a percentage. Okay. Percentage of the population who will pick an answer that lies within the interval, the plus minus 0.4 just now, right? How confident you are. So these are some of the common ones that people use lah, 95, 99, 90. Yes, and then now comes the formula. Okay, so your mean is in the center. The confidence interval is the formula. X bar, which is your mean, minus Z alpha over 2, divide by sigma. Sigma is your standard deviation. Divide by square root of n, sample size. So complicated, right? And then on the right side, is x bar plus z alpha over 2 times standard deviation divided by square root of the number of samples that you test. So actually, right, if you see the left side here and the right side here is actually the same, right? The only difference is this one minus, this one plus. So we can actually combine these two together to become like this, plus minus your interval. Okay, so you can combine left and right. Later we'll take a look at the example. Like. Okay, let's see this. How to find Z alpha over 2. You already know this, right? Standard deviation. You already know sample size, easy. You already know the mean. What the heck is this? So this is where you will have to use another table, okay, to find out. Anyway, let's do step by step. So this question is 95% confidence level, right? So firstly, you convert from percent to a decimal place, which is 0.95. Now, the formula says alpha over 2. Alpha is the confidence level. So you have to divide by 2. So now you have 0.475. But now I don't want alpha over 2. I want what is the z value of alpha over 2. So I now have alpha over 2 here, 0.475. What is the z value? So you have to use this z table. So the z table will look something like this, okay? Doesn't matter. What we want to know is what is the z value. So this is not the table or the graph we were looking for. Wait a minute, So we have to now open up the z table. Okay, give me a minute to open this up. Okay, so let's go to the z table. So obviously, this table will be provided to you if this question is asked. Okay. Okay, so let's see. So when you look at the Z table, the alpha over 2, right, is all here. All this mess of numbers. Okay, that's your alpha over 2. So your 0.475 is somewhere in here. Okay, now I have to find the Z value from the alpha over 2. Okay, so alpha over 2, as I said, is all in this mess of numbers here. So you have to use your eyeballs and find out where is 0.475 based on the question, right? Let's go back to the question again. Yeah, 0.475. Huh? So 475, if you use your eyeballs, is here. This one. All right. So where now can we find the z value? Can you see the z value here? The z. So what you should do to find, there's two. One is the vertical one is the horizontal one. So how do we get the z value? Okay, let's extrapolate first, okay? So horizontal, we need also the vertical one. Yeah. Okay, and then after that, you find the z value. So the vertical one right here is the first decimal place. So the first decimal place for z value of alpha over 2 of 0.475 is 1.9. But z value always is two decimal place. So this on top here is the second dp. So here 0.475 is actually at the 6 there, right? So it's actually your z value will be 1.96. And that's how we get the z value from the alpha over 2, which comes from your confidence level. Okay, so the z is 1.96. This is the second dp. Or if you want, you can 1.9 plus 0.06, which is still the same 1.96. Okay, So the difficult part is to find in this mess or number in the center here, where is the confidence level. So that's how we get this 1.96. Okay, so you go and try it out and see. So this is the hardest part. Once you get this right, you can use the formula to calculate your confidence interval. So you can try out this one. Okay, so you go and try out, see whether you can get. So don't forget, alpha over 2, you must divide the percentage by 2, so you get 0.49. Okay, 4.94 is 0.47. Okay, this one, let's see, yeah, that's the table here. So it's what, 0.49, right? Okay. Okay, if you use your eyeballs correctly, okay, 0.49 is actually not there. Where is this? It's actually right in the middle of these two guys here. Correct? 0.49 is 0.4900, right? But here is 0.4901. Here is 0.4898. Where got 0.4900? Don't have. Why is this? Okay. So when you have this type of values, right, that you cannot find, but it lies somewhere between two values, always take the value to your left, which is the smaller value. So in this case, it will be 2.32. This is from 2. So it's 2.32. Okay, because it lies in the center, take the smaller one or the left side, which is 2.32. So your Z value is not 2.33, it's 2.32. Got it? That's why it's 2.32. Okay, next one is 0.47. One more last example. 0.47. I don't think you can find this also. Oh, it's here. Okay, let's see. Difficult, right, to find. Easier. Okay, so 0.47 is 0.4700. So it's in between 4699 and 4706. So take the smaller one again. So it'll be 1.88. 1.88. Okay. So likewise, you can do the same for 90. If you do a lot of times, right? If usually 95, for example, always come out, you roughly know that it's 1.961. They won't change because it's 95%. Okay. Okay. So if you want to look in terms of the normal distribution curve, it will be like this lah. Okay, your data is all in the middle in the boundary of Z 1.64 to 1.64 plus minus. Okay, this is more important. This one is the calculation. So you have a sample of 50 people. N is 50. SD is standard deviation. So SD already given 6.8. The mean is already $19. So all given. So now you have to find what is your Z value of alpha over 2. Okay, so do like this. And then 95%, right? Yeah, 95%. Just now we covered already. The Z value will be 1.96. Then once you get this is the hard part from your Z table. Just substitute in the formula lah. 19 plus minus 19 your mean plus minus 1.96 times standard deviation divided by square root of 50, which is your n. And you should get 19 plus minus 1.88. Okay, you express as plus minus 1.8 is fine enough. We will give you the marks for this. But if you want to expand out 19 minus 1.88, which is 17.12, 19 plus 1.8, 20.8, also can. Right. So same thing here, 90%. So 90 divided by 2, 0.45. 0.45, use your Z table. You should get 1.64 from 0.45. And then substitute inside and you should get these values here. Okay, same thing here. 415 students. Okay, average 5,000 hours. So you're given the mean, you're given the SD, standard deviation 900. Find the 95% confidence level. So again, do the same thing. 95 by divide by 2.95 divided by 2.475. Use the Z table. Just now we already give some example, right? 95% is 1.96 Z table. Substitute it inside. Okay, the mean 5,000, SD 900, standard deviation, square root of 415 because this number of students. And you should get this answer 5,000 plus minus 86.59. Okay, so this answer is enough already. Or you want to explain out also can. But then there's an additional question here, right? They ask you if a parent claimed that the children watch 4,000 hours, would the claim be believable? So all you simply have to do is you take this value 4,000 and is it within this range or not? No, right? Because the range is 49 to 5,000, right? But that one is 4,000. So it's not within this range. So therefore, it's not reasonable. That's all. Okay, if it's within the range, then it's reasonable. That's all. Straightforward. Okay, another question here. This is, I think, one part of the exam question. Anyway, now SHP, no more exam really. Okay, so the mean is given, SD given 14, calculate 95%, again 95%. So you should know that the Z table, even without looking at the Z table, it should be 1.96. Okay, 0.475. Look at that. Z is 1.96. Just substitute inside lah, and you should get these values. So you when you calculate, right, you only calculate this right side here. Okay, the mean just stay there unless you want to expand out lah. So you can just calculate the right side here. You get 150.55 plus whatever you calculate here, 3.92, and that's enough already. We give you the marks. Here you don't need to expand out. All right, so that's all. So again, if you got any question, please don't forget to check with us. Thank you.